Hello, my name is Laure Leblanc. I work for the TI OMAP group. I'd like to welcome you today in our automotive section, where we have a demo for you that basically shows Android, but it has a lot more to it than it seems. What we're showing here is basically a way to answer the paradigm that automotive manufacturers are trying to solve, where they're trying to have the rich experience of Android, but at the same time answer their safety concerns about bringing such a high-level OS to the car. They're also concerned about being able to fast boot this system. To answer these problems, we've been working with Green Hills. We're going to show you this demo today, which we believe is an industry first. To help me in this presentation, I have my colleague Joe Faber from Green Hills. He's Director of Platform Solutions. He'll walk you through the demo.
Thanks, Laure. So I'd like to go ahead and take a look at the platform. And as Laure mentioned, we have a fully virtualized Android system. We've not modified any of the code of Android, and we're running this on a virtual machine that's running on top of the Integrity real-time operating system. So this Android looks and feels exactly like it does on the native hardware. I can quickly zoom back in and out of different applications. One of the typical applications that you might find in a car is a navigation application. This application is enhanced. We'll go ahead and start the car going down the route. It's a 3D mapping application with voice indication. We can zoom in on this map and get a building level view. The responsiveness is very nice. And go back out. So fully 3D capable. Another thing that we wanted to really do is to ensure that the user experience is very nice, especially with regards to the fluidity of the graphics, is have run some benchmarks to make sure that we're getting maximum performance out of the CPU. So this is an Android benchmark called Nanomark that measures GPU performance. When we run this benchmark natively on Android on the OMAP 5, we see about 67 to 68 frames per second. When we run the same benchmark on the hypervisor with the operating system running underneath, we'll actually see the results here in a moment, but we're getting right around 65 frames per second. So the overhead associated with running Android in this virtual machine is very low. So you can see the results of the benchmark here, 65.2 frames per second. Now, as Laure mentioned, we also have a bunch of capabilities that are available natively on the Integrity real-time operating system. Integrity is a safety and security, has a great safety and security pedigree, the best of any operating system in the industry. So one of the native Integrity applications that we have running in this demonstration is the rear view camera. And we're using this USB camera. All the USB processing is being handled completely by Integrity, and we're also doing alpha blending, taking advantage of some of the hardware capabilities of the OMAP 5. So I can come over to my debugger, and I've got connections to all of my different tasks that are running on the system, and I'll start running that rear view camera application, and there in the background we can see Laure waving to us. Move the camera around, it's very responsive, and that entire application is completely under the control of the Integrity real-time operating system. So when you put the car in reverse, Integrity guarantees that we'll always show this and it will always have the resources it needs to execute. So the last thing that we'd like to show you today are the fast boot capabilities of the Integrity real-time operating system. When you get in a car and you put the car in reverse, you need your camera to be available immediately. And so that application is under the control of Integrity, which has instant on capabilities. So I've actually powered the board down at this point, and we want to show you just how fast Integrity comes up. So I'm going to reach over here and I'm going to power the board up now. The splash screens come up in just a few milliseconds, and then we initialize that USB camera and it's already up. It actually comes up in less than 2 seconds, which should meet all the federal government requirements that we believe are on the way for rear view camera applications. In the background now, Android is starting to boot. You can see Integrity is doing that alpha blending. And so we've got our real-time critical tasks and fast boot critical tasks in combination with that rich multimedia experience that Android can give you. If you're interested in getting more information, you can go to www.ghs.com.